Revolup is our post-consumer recycle resin. Post-consumer recycle, or PCR, is where the flexible film or other plastic packaging has met its end-of-life potential and then has been collected, cleaned, and sorted, and can then be turned back into a flexible film application. Incorporating Revolup into plastic packaging allows us to decrease the carbon footprint of the application.
So good morning, everyone, and welcome to Material Science in Action. So I will be welcoming here several of my colleagues to do a presentation to you today, which is about all materials development we've been making in order to give you quite a wide array of applications and examples of what we've been doing. So I will be accompanied with three of my colleagues. So first of all, Edith Bershi on the left, who is the Global Marketing Manager for Wire and Cable at Dow, followed by Pepa Contanda, the TSND scientist for all development in the field of polymer science. And then we have Jérôme Ritiema, which will be speaking us also about new PCR development he has made recently and some applications which are really highlighting. So first of all, for the ones who don't know us, we are Dow. We are a global company, $40 billion US. We are headquartered in the US, and we have 3 large production hubs in Europe, where we have crackers and derivative polymers and advanced chemical production. We are active in many market verticals, being building and constructions, wire and cables. It could be inside also packaging, consumer solutions. So we have developed a wide array of polymers that are derivative from a lot of waste, as you can imagine. Our ambition is to transform several million tons of waste into the polymer of the future. So we've made this commitment several years ago, and we are pursuing this journey to bring you circular materials by investing into new technology, such as advanced recycling, biocircular, as well as mechanical recycling. So today, we're going to focus on mechanical recycling. So my colleagues will speak to you about several of technology, as I told you before. First of all, what is Revolup? Revolup is our market franchise to develop high-quality PCR solutions that can go directly into high-end applications, not only in packaging, but also in wire and cables, in durables, consumer applications. So those products have been tuned to do the job. They are certified. They have a very high standards in terms of product stewardship. They are also developed to go back into a same application as they are coming up. For example, if you use stretch film for palletizing your product, you can use our PCR back into the stretch film. So this is only one example, but my colleagues will highlight to you several of them coming up in a minute. Okay? Ready to hear more? So now, to whom I'm going to ask a question. Napoléon mangea allègrement 6 poulets sans claquer après. So yes, actually it's Jérôme who is going to talk about few examples. So Jérôme, what did you do in terms of PCR development? Can you give us more?
Yes, good question, Fabrice. So at Dow, we have been working on the development of several grades, PCR grades, that go into the packaging applications. I want to highlight here in specifically one example. So it's a grade we developed that is based on household waste, rather than where you typically see a lot of logistic waste. We developed a grade that contains 85% of PCR coming from household waste. And this has been used by RKW, one of our customers, to make a shrink film, the shrink film that you see here. It contains 70% PCR overall, half of which, so 35%, is PCR coming from household waste. And this product is called My Multipack, and the nice thing is that it's called My Multipack because it's basically the film that you and me, all of us, as a consumer, have thrown into the bin and is now recycled back into that same shrink film again, right? So I think this is a really nice example, and in fact, this has been nominated one of the finalists for the PRSE award for tomorrow.
All right, so you hear me? Yeah. So right, it means that this PCR is coming right from the yellow bin, right?
Yes,
in fact.
exactly. Yeah.
Okay. So did you have to solve other challenges for other applications? Did you develop something new as well?
So yes, in fact, we have been working on different applications. So in the past year, we've been more focused on stretch wrap, so the pelletization film for load security. And what we have been developing here requires different aspects. As you know, a stretch wrap is typically a thin film. So think about 17 microns. After you stretch it, you get well below 10 microns. As you can imagine, controlling the consistency of the PCR and the gel levels is really crucial to make this work. And specifically when we talk about machine stretch wrap, right, which is a high performance application. And what do we need there, right? So for those of you that work in this, you know, right, you need elongation, be able to stretch the film, you need good mechanicals so the film doesn't break, tear resistance, puncture resistance, and you need the good processability. So you're able to stretch this, to process this efficiently at high speed on industrial line. And to work on all of this, we make use of several factors. So we have on the material side, you need, of course, a good quality PCR. You need high-performance virgin resins. And also you need, of course, the expertise of how are you going to combine this, which PCR with which virgin resin, how do you design a multi-layer structure. And to help with this, we have here, as you see, our PAC studios, our equipment, highlight, a RoboPAC, acceleration bench, so we can make sure our solutions not only work on paper, but also work in a real-life scenario.
So what type of challenges did you have to overcome, in fact?
So to overcome this, let's say two of the key properties, they are here. So those elongation and the tear resistance. Of course, we need to be able to stretch the film to make sure we have the right load stability after wrapping the film on the pellet. And obviously, you don't want it to break, right? Typically, when you start wrapping the pellet in the machine, you apply pressure on it, and you encounter any large gels is the moment when your film starts to tear. And so this is what we have been testing. So looking at the elongation, we see we can get pretty good levels. Of course, if you look at the benchmark, which is here, the very high performance version, it's not on that level yet. But can we use this for high performance machine stretch wrap? The answer is yes. We have tested this. This works. Elongation is good. And also the tear resistance, as obviously, you don't want during the wrapping process that your film breaks, right?
So high PCR content is such a challenging application, right?
Definitely. I mean, if you look at the numbers, if you look at stretch wrap, machine stretch wrap, how much PCR is being incorporated there nowadays, we are talking maybe 3% in the overall market. So we are pretty far off the 35% PPWR target for 2030. That 2030 seems far away, but it's really around the corner. So there is still a lot of work to be done there.
Okay. So all the best to you in this development and embarking our customers in the same value chain to make it happen, right? So now I'm going to ask Edith. So Edith, I think you had to overcome also some challenging in wire and cable, because I've been told that generally you don't accept any deviation from standards here. It's a very normed application. So how could you overcome this challenge? So give us an example about PCR in this application.
Yeah, thanks, Fabrice. Indeed, wire and cable is a very challenging application because, as you can imagine, as you see as well in your homes, the cables need to operate for a very long time, for several decades, and they also need to meet industry requirements. So we have developed and launched our Revolup 3215 BK cable jacket material, which is an LLDPE-based jacket. It's a black one, and it's suitable for power and telecom cables as well. And the cable jacket is basically the first line of defense for the cables, so it's quite difficult to find a solution that meets industry requirements and can operate for long times. We have designed this material to combine convenience, efficiency, and quality. It's a fully compounded solution, so it comes in one pallet, so cable manufacturers can use it as is on their lines, so it allows single inventory management. And in addition, thanks to our very high standards for quality control, we basically can give consistent quality, and through that efficiency during the cable manufacturing process that comes with easy processing and basically matching the virgin performance.
So I guess it must have been very challenging for your customers to accept such a product, right? So what did you do to overcome these challenges?
Yes, thanks. So indeed, I would say that there are three key elements that was taken into consideration when designing this material. It's the long-term mechanical performance, withstanding the environment, so weatherability, and the processability. And we aimed to add circular content and at the same time not compromise on the performance. And so basically, for the first one, the long-term mechanical performance is very important because, as I said, cables need to operate for multiple decades, and it is also at a high temperature. So we need to simulate the lifetime of the cable. And that's done through heat aging. And the cable is aged under certain conditions that are set in the standards, and the tensile properties are measured before and after aging. And the standard says that these properties shouldn't change more than 25%. And as you can see on the graph, with our Revolup 3215BK, the tensile properties after aging are well within this 25%, so the material shows excellent stability. The second key requirement is the weatherability, so the cable to be able to withstand the environment. And that's measured through ESCR, which is environmental stress crack resistant. And usually PCRs show a lower ESCR because they already went through some processing during the mechanical recycling process. However, with our 3215, we have been able to design a material that has an impressive 4,000 hours ESCR measured under industry standard conditions without any cracks. And as I mentioned at the beginning, the third key requirement is processability, because obviously cable makers don't want to change their parameters. They want to run just as quickly on the cable manufacturing as before. And for that, we looked into the resin rheology of this material. And as you can see on the graph, the resin rheology is basically, of this 3215, is matching the rheology curve of the virgin LLDP black compound, which is the equivalent for the one with the PCR content. So it also helps with the processability. So overall, I would say that thanks to our material expertise, we can offer to the industry a material with 30% recycled content matching the virgin performance without any compromise.
All right. So you must be successful on the market already, right?
Yes.
Is it available?
Proud. Yes, this is available.
All right. Well done. So now we're going to go to the field of polymer science. So you know that in order to facilitate and encourage more recycled content, you need the right polymers. So Peppa is going to speak to us about this new development that she has made that are also validated to be the finalists. So Peppa, can you please tell us more how polymer modifiers can really change the game here?
Of course. So as we all know, like recycled polymers don't perform the same as virgin materials, right? So if we want to move to a sustainable future, we should use polymer modifiers. Normally, when you recycle a material, we have two main issues. One is incompatibilities, and the other one is polymer degradation. So with polymer modification, we can compatibilize incompatible polymers, but also we can improve processability. So processability gets worse with recycling because of two mechanisms. Sometimes polymers cross-link, and sometimes there is change cleavage, right? The polymers become smaller, so you you increase the melt index, so it's not for a bow. So we have different chemistries for different polymers, depending on which recycled stream you want to modify. We can offer a different polymer modifier.
All right. So which are the performance challenges when recycling? Specifically, I think the one you've been working very hard, ABS.
So ABS is a very, very, you can say this?
No.
Yeah. So it has a very good impact on mechanical performance. Also, it has dimensional stability. very high gloss, a nice glossy surface, and also is very good electrical insulator. So this is used in many different applications that range from automotive, electronic appliances like TVs, toys. So in areas like automotive, for example, the European Commission has already established limits on the amount of recycled material that have to go into cars by 2030, right? So if the rest of applications follow the trend, like has happened with packaging, by 2030, we won't have enough recycled material to meet the demands. So here is where polymer modification plays a very important role, especially in ABS, because recycled ABS, we know that is less tough, is more viscous, so worse processability, and also aesthetics are worse, like it has more gels, like it's not, the surface is not so glossy. So we can help do all this with polymer modification.
So then, I think you're going to speak about a magic product now. Can you let us more?
I will. So for ABS, as we mentioned, we have different challenges that can all be solved with one polymer modifier. Our polymer modifiers for recycled ABS are our Elvaloy AC product line. With Elvaloy AC, you can improve the processability.
Sorry, it doesn't work. You've been doing something on the computer, I guess. All right, thank you.
Perfect, thank you. So we can improve mechanical performance. You see, like with 10% Elvaloy AC 1330, we can improve impact by 40% compared to recycled ABS. We can reduce viscosity up to 20% also, improving processability. We have also a considerable improvement in surface appearance. This is very, very key for our Elvaloy AC polymers because incumbent impact modifiers are detrimental to surface appearance, gloss, viscosity, but our Elvaloy AC can improve compatibilization of incompatible particles, at the same time improve gloss, and at the same time improve impact performance. So we have a unique solution in the market that can be applied not only to ABS, but also to high-impact polystyrene, polycarbonate, polyamides. So we have 4 different solutions, but specifically for this technology, we have nominated for the PRSE award that will be announced tomorrow in this same room. So I hope to see you all there. Yeah, fingers crossed.
Thank you very much. I think I don't want to close it before going Q&A. Just wanted to ask you some last questions. So Edith, first with you. What are the key priorities for you in 2025?
And the key priorities for 2025 are to developing power jacket, cable jackets for other applications as well, HDPE base, for example, and to increase the recycled content.
Okay, more and more. All right. For you, Jérôme.
So for me, the main objective is to develop solutions to help our customers meet the PPWR targets, right? With a special focus on those applications where nowadays we are pretty far off, like machine stretch wrap.
Pepa?
For me, in 2025, I hope to expand our impact modification portfolio and be able to have the best performance of recycled material to be able to match virgin products.
So where can we see all these innovations?
We have a booth.
Yeah? Where is it?
Q9.
All right.
On the balcony.
On the balcony. So yes, you can look at everyone. Huh? I was this morning spying people, you know, so no, it's okay.
Very nice.
All right, so please come to visit us. We have a small booth, but nice people. And we will be welcoming you to show all these innovations. And I'm going to take the Slido for the Q&A. Interactions. All right. So maybe a question I could ask you. So we have, all right.
I think these are probably questions from the previous session.
Yeah, they're
Yes.
related
On the pad.
questions. Yeah.
So, yes. This is the question. This one, okay, all right. Yeah, because I was seeing other question here that I don't see here. Okay, thank you. So it's a question for you, Peppa.
Okay, lucky me.
Do impact modifiers pose a challenge on recyclability then? If you if you modify the polymer, does it pose a challenge in the next cycle of recyclability?
Actually not. Actually, it will easy up your recyclability in the second cycle because these polymers don't degrade when you process them.
Mm-hmm.
So then they are already there when you use them again.
So they compensate
Yeah.
for the next round.
Mm-hmm.
Okay, perfect. So there is a question related to when there will be mechanical recycled PCR solution available for food contact. Who wants to pick this up?
Okay, I can take this one. So for food contact applications, I mean there are limited examples available. Like perhaps if you look at other regions first, like if you look at the US, you have there some examples which have the so-called FDA no objection letter, no, which means okay, these grades can be used in food contact. Now in Europe with the EFSA, things are a little bit more strict. So it's more difficult here to get the food contact approval. Now, if you think about some things like recycling of bottle caps, for instance, you have a specific source which is pretty clean. Now here you can probably get this also no objection letter for food contact. If you talk about more general mechanical recycling grades, like coming from film, that for now is not possible yet. But I think with, let's say, with advancing the technologies we have on extrusion and cleaning and washing and sorting overall, in the future should be possible.
A question I maybe answer. So what is your PCR stream? How pure are these streams? So here, as you have heard from Jérôme and from my colleagues here, we've been developing polymers, the Revolut brand, based on different feedstocks. So some of them are based on commercial waste, which is, the waste that you have at the back of an office, of an Amazon plant, let's say, where you take the waste and you transform it into a valuable PCR. But we've been also developing in the field of collation shrink film a high PCR content with household waste. That was a bit more challenging, right? That's what you explained to us. But it's really where we think in the future the market will have to go to be able to digest those type of waste streams, which are a bit more difficult to transform into high-quality PCR. So as a summary, we do use several sources of different PCR, both from commercial waste and from, as well, household waste. So there are a lot of questions, so sorry about that.
I see another question here on the screen. Maybe I can comment on what's going to be the share of all the sustainable options that we have now. So mechanical recycling, chemical, and bio-based. Now, this is, let's say, not only looking at us as Dow, but as in general in the industry, the prognosis of where we're going to be in the next coming years. Both mechanical and chemical recycling are going to play a big role, right? So, perhaps roughly equal, or even mechanical recycling going to be the bigger one. And I think, okay, the bio-based, because of material availability, will be a smaller fraction compared to the other two.
All right.
And in line with that question, I think that there was one as well about how is AR and MR conflicting.
Yes.
I think that we can say that how we see it is that these are complementary technologies and not conflicting technologies.
Exactly. That's why we made several investments. You may have heard from the news. We have bought a mechanical recycling company. We have also invested into advanced recycling companies because there is, we think, not a single way to solve the waste challenge problem by using different technologies like biocircular as well. So we are covering the 3 platforms. So, question to you, Edith. We managed to incorporate PCR content in the cable housing. Why isn't the recycled content higher?
We are working on that, and of course the first part is that we need to have as I mentioned, the cable need to operate for a very long time, so reliability is a key question. And it depends as well on the quality of the recycled content, and we see that with the right quality that we have today, we can potentially improve the content, the PCR content, so that's coming, I would say.
So do you plan to have other part of wire and cable application using PCR?
Cable jacket is the obvious application because it doesn't need to have electrical properties. Insulation material is much more challenging because that needs to have the electrical properties, the tensile properties as well. For that, maybe advanced recycling is an option. On mechanical recycling, due to reliability, there is no solution yet.
Question of life cycle for you, Peppa. How does it translate when you put alloy into recycled ABS? Does it increase or decrease the life cycle, the carbon footprint? Do you have some data on this?
I don't have data on it, but I would say that it reduces because alloy AC has a very low carbon footprint compared to ABS.
Okay.
So I would say that it would reduce it, but I don't have data on it.
So it goes in the right direction?
Yes.
Okay, perfect. That's good news, right?
Yeah.
So Jérôme, I let you have a sip of water. So then what are the next applications you are developing as well? Or let's say, tell us about the success that we made. I think there is another application in packaging.
Yes. Yeah. So actually, one of the applications we will come with soon that we've been working on recently is stretch hood. And it's another, if you look at the industrial packaging, another challenging application where we need to get very good elasticity and stretching of the film. And here we also developed a solution combining PCR material with our virgin resins. Definitely more to come. We will launch that a bit later this year, probably in the next coming months.
All right. Do we still have some time or no? It's okay. All right. Thank you very much for attention. Please come to our booth. We'll be welcoming you the 2 days. And if you need also to meet, to discuss, we have a meeting room. So we are ready to welcome you. Thank you.
Thank you.
Revolup is our post-consumer recycle resin. Post-consumer recycle, or PCR, is where the flexible film or other plastic packaging has met its end-of-life potential and then has been collected, cleaned, and sorted and can then be turned back into a flexible film application. Incorporating Revolup into plastic packaging allows us to decrease the carbon footprint of the application